Gloucester students, here I am again in room 149, and I'm going to do our final video about simplifying. And this time we're going to simplify more complicated expressions so we can determine if our expression is a linear or a quadratic expression. So this lesson is really geared towards grade 10 and grade 11 students. So here is my expression. It's a polynomial expression. It's got letters, it's got numbers. We see we need to multiply first, and then we have to simplify and make it shorter. So let's first always start with the multiplication, because when we're doing BEDMAS tells us we should do multiplication before we do addition and subtraction. So here I have minus 4x squared, that's not changing. But here in the middle, this is where the multiplication is happening, because I've got this 2x right up next to the bracket. So that means I need to multiply the first part by 2x and the second part by 2x. So if I do 2x times 2x, 2 times 2 is 4, that's plus 4, and x times x is x squared. And then I have 2x times minus 3, so that's going to be minus 6x. And then I'm writing the rest down, the plus 7 minus 4x. Our next step is we need to combine like terms. Like terms just means combine the things that are the same. So let's start with our x squareds. Here we have a minus 4x squared, and here we have a plus 4x squared. If I have negative 4 plus 4, that gives me 0. So I could write down 0x squared, or I can just write down nothing. I don't need to write anything. And then here I've got minus 6x minus 4x. So negative 6 subtract 4, that's going to give me negative 10x. And then I've got my plus 7. So when I look at this, I'm going to rewrite this a simpler way. I don't need that 0x squared. I'm just going to write negative 10x plus 7. And if I want to graph that, I can see that my rate of change, or my slope, is negative 10. It's jumping down 10 every x, and it's starting at 7. So I'm going to say that if I had x's and y, if this was equation y, it would start at 7 and then continuously drop down 10. So 1 minus 3, 2 minus 13, 3 would be minus 23. And that clearly is linear. It's always dropping negative 10. The slope is negative 10. It's always the same. It's constant. Just to make sure it's linear, I enter the equation into Desmos. And you can see that Desmos creates a decreasing line because it's going down 10 each time. The slope is in negative, and it starts at 7. So Desmos has helped me show that it's linear. What I think is really neat is if you go to Desmos and you enter your original expression, the one that was minus 4x squared plus 2x times 2x minus 3 plus 7 minus 4x, you still get a line that starts at 7 and is decreasing by 10 each time, because when you simplify that big long expression, the simplified version is just minus 10x plus 7. Let's try another expression that starts off big with x squareds and x, and let's see if it also simplifies to make something linear. So here I have minus 4x squared, that's not changing. Here I have minus x. I'm multiplying this minus x by the two things in the bracket. So minus x, minus x. And in front of that minus x, there's actually an invisible number 1. So that means I have minus 1 times 2 gives me minus 2. And x times x gives me x squared. And here I have minus 1. There's a 1 right here. You can't see my 1. Minus 1 times 3, which is minus 3. And then I've got that x. And over here I've got plus 4. So I'm going to look at what I have and try to simplify it. Okay. I've got minus 4x squared. I've got minus 2x squared. Those are the same. They both have x squareds. So minus 4x squared minus 2x squared gives me minus 6x squared. And then I have minus 3x and 4. Now, does this look like something that's linear? Does it look like a part that has a jumping number and an initial value? Or does it look a little bit more complicated than that? Let's check with Desmos and see what type of graph we get. And this time when we use Desmos, we see that when we enter the simplified expression minus 6x squared minus 3x plus 4, if we were to graph it, it's no longer linear. It's actually a type of graph called quadratic. And if it's quadratic, in the equation, you'll often find the x squared. So that x squared that we see is a good sign that it's going to be quadratic. So today, as you're trying the harder simplifying questions, when you get to the end, I want you to ask yourself, will this expression, will it produce a linear graph or will it produce a quadratic graph? And then I want you to use Desmos to check to see if you are correct.